Let us zoom in on the first stop in our outline: the historical context and recent developments in the field. Neural networks may feel like the hot trend right now. Everyone is talking about ChatGPT, self-driving cars, AlphaFold, but they have been around since the 1950s. The recent explosion in application isn't because the math suddenly changed. It is because we finally have the data, the computational power, and the software ecosystem to make them work at scale. So in this intro, we are setting the stage, not with equations just yet, but with context, where these fields came from, how it evolved, and why neural networks matter across domains from medical to Mario Kart. All right, onward to some history. So why neural networks? Why now? The truth is, this stuff lived in the academic backwaters for decades, until suddenly it started solving really big problems. Take disease prediction. In 2018, Google's Verily trained an AI to detect heart disease risk just by looking at retina images. No stethoscopes, no lab work, just pixel-level inference. Same in games. AlphaZero learned chess, shogi, and Go in hours, and then crashed the top human players and AIs. If you have seen those DeepMind videos, you know what it looks like when a system truly learns from scratch. And natural language processing, NLP, took off around 2011. That's when we saw the first real breakthrough in understanding language at scale. Not just word prediction, but actual semantic modeling. Fast forward a few years and you get transformers, GPT, BERT, and well, probably the AI making the slides, writing the scripts, and doing the video. All of this builds on the foundational idea we're exploring today, that we can approximate complex functions by stacking lots of simple functions, neurons, together. Let us fast forward to 2020. This is where things really start to pop. First, protein folding, a biological problem so tough that Nobel-level scientists struggled with for decades. Then, DeepMind's AlphaFold came along and, well, solved it. Not approximated, not sort of, solved. They shift biochemistry research method overnight, from slow lab work to model-driven hypothesis generation. And if biology isn't your thing, how about autonomous driving? AI models can now identify pedestrians, lane markings, road signs, and sometimes even potholes, which is crucial if you have ever driven in Boston, where dodging potholes feels like a video game. The technology is still learning, but it's already better than that one friend who insists they don't need GPS. Next, let's talk about space. In 2019, the Event Horizon Telescope team gave us the first ever image of a black hole. That fuzzy orange donut you have probably seen? Yep, that's the result of a clever reconstruction for sparse frequency data, a task tailor-made for neural networks. And speaking of image generation, tools like DALL-E now lets you generate bizarrely detailed images from plain English prompts like a koala dunking a basketball. But maybe you are not a visual person, maybe you prefer code. Good news, neural networks can write that too. For suggesting code completion in IDEs to writing entire function on demand, tools like GitHub Copilot are already changing how developers work. And of course, we now have conversational AI, whether it's customer service bots or that chat assistant that accidentally solve your math homework. It's all built on language models trained using neural networks. Let us circle back to medicine. In 2023, Google introduced MedPalm-M, a large medical model trained across multiple languages. It answers questions, explains diagnosis, and even reasons through uncertainty. And just like that, we're seeing AI move from supporting tools to second opinions. It's not replacing doctors, but it's becoming the kind of assistant you will actually want in the room. Finally, meet YOLO, short for You Only Look Once. It is not just a lifestyle slogan, it is a real-time object detection system that can recognize people, traffic signs, cats, coffee mugs, you name it, in a single pass through an image. By 2024, YOLO models were being used everywhere, from warehouse automation to real-time drone vision. In other words, the machine looks once and gets it right. If only I could do that with my emails. Next up, the holy grail of generative models, text to video. We have gone from still images to full motion video, generated from nothing but text prompt. A recent demo by Sora, OpenAI's model, used this prompt: a cozy, isometric, retro-futuristic miniature world with spaceships, comets, and beautiful planets. And the output? Think Blade Runner meets a Pinterest mood board rendered in 8K. This is not just fun, it's reshaping storytelling, advertising, and education. Just imagine describing your final project and watching it animate itself. Now, before we get too starry-eyed, let's talk about challenges. Neural networks are powerful but not neutral. Consider this. Job screening models have shown gender bias, favoring male candidates, even when trained on seemingly fair data. Or risk assessment models in courts, some models have shown racial bias, disproportionately flagging black defendants as high risk. These aren't edge cases. These are systematic failures when models learn from bias patterns in historic data. So as we learn how to build these models, we also need to learn how to interrogate them, evaluate them, and when needed, say no to the predictions.